Welcome to Angles of Rotation. Today's objectives are to draw angles in standard position and to determine the value of trig functions for angles in standard position. So at this point you should be aware of what an angle is, but you may not have heard of what an angle in standard position is. We say that an angle is in standard position when two things are happening. One, when the vertex is at the origin, and when one ray is in the positive x-axis. So these angles are going to be on an x and y plane. So here's my x and y plane, and I'll draw an angle that's in standard position. So for example, I need an angle where the vertex is at the origin and one ray has to be on the positive x-axis. Here's the x-axis, here's the y-axis. So one ray is on the positive x-axis. The other ray can be anywhere, really. So let's just say it's right here for now. Now we have names for both of these rays. Now if the ray is on the x-axis, we call this the initial side. You could think of that as when the angle starts. So this ray right here, this is on the initial side. For the other ray, that's where the angle ends. So we call that the terminal side. Now, angles can rotate positively or negatively. And we'll look at two examples of that now. So for this one on the left here, let's say this moved in the positive direction. So whenever you talk about a rotation, you start on the initial side and you go to the terminal side. So we can say that's a positive rotation of about 135 degrees. Each one of these quadrants represents 90 degrees. So we'd call this a positive rotation. Now, what does a negative rotation look like? Well, let's draw another x and y axis here. I have my angle in the standard position with one ray right here. And then let's say the other ray was here. So in this one, in the positive rotation, I went counterclockwise. For negative rotation, you go clockwise. So we would say this rotation right here is about negative 45 degrees. And that is what an angle in standard position is. Now let's draw some examples of angles in standard position. So for the first one, let's draw a 300-degree angle. So I draw my x-axis and my y-axis. I start my angle right here in standard position. This is the initial side, and then I count over. So right here, this would be 90 degrees. Right here, this would be 180 degrees. If I add 90 to that, I'll be at 270. But now I have to get to 300. So right here I'm at 270. what do I have to do to get to 300? I have to add 30 to that. So I go about a third of the way through. And this here is a 300-degree angle. So just remember, each one of these quadrants is 90 degrees. And that should be more helpful to figure out what's happening here. So that's a 300-degree angle. Now let's try a negative angle. Let's try negative 105. Okay, so draw my y and x lines. I start my angle in standard position, and then I do negative 105 degrees. So now I'm going clockwise. So I know if I go from here to here, that's 90 degrees. I have to get to 105, so I have to add 15 more to that. That's about right there. So that angle there is negative 105 degrees. Now let's try one that's greater than 360. Let's try one that is 400 degrees. Okay, so it's a positive angle, so I know I'm going counterclockwise. So I start here. Now let's count. 90, 180, 270, 360. Now here I'm at 360. How do I get to 400? I have to add 40. So I go a little more, and that is my 400-degree angle. So angles can be negative, and they can also be greater than 360. The next concept we want to go over is coterminal angles. Coterminal angles are angles in standard position that have the same terminal side. So you can have 2 coterminal angles, 3 coterminal angles, but they're basically angles that end in the same location. They have the same terminal side. So for example, let's look at the measures of 120 degrees and 240 degrees, negative 240 degrees. Okay, let's draw these. So if we draw 120, we have 90, and we need 30 more to get to 120. So this is 120 degrees. Now let's look at negative 240. So we start in standard position. We go 90, 180. How do I get to 240 with 180? I have to keep going with 60. And if I do that, I see that it lands right where the other angle landed. So coterminal angles are angles in standard position that have the same terminal side. Now there are infinite many coterminal angles. You can keep adding and subtracting and end up with angles that land on that same side. So one way to find the measure of an angle that is coterminal with another angle is to add or subtract 360 degrees. Now that makes sense because let's say we started off with an angle at 0 degrees. So this angle here is 0 degrees. If I want to find the measure of an angle that landed on that same side, I would just add 360, and then I'd be right back there. I can either add 360 or I can subtract 360. So to find more coterminal angles, just add or subtract 360 degrees. Alright, let's find some coterminal angles. So let's find the measures of a positive angle and a negative angle that are coterminal with each given angle. Alright, so for the first angle we want to work with, let's say that theta equals 40 degrees. So we're working with a 40-degree angle. So let's draw that one first. So if we draw 40 degrees, we end up with an angle that's about here. Now to find coterminal angles, all we want to do is add 360, which gives us 400 degrees. And that's our positive, so we're good there. And then we need a negative, so we subtract 360. And we end up with negative 320. Now these both make sense. Let's draw both of these. Let's draw 400 degrees first. So we start here, 90, 180, 270, 360. To get to 400, I have to add 40. So we're good there. Now let's draw negative 320. So I start here, negative 90, negative 180, negative 270, and to get to negative 320, I have to go here. So once again, just add or subtract 360. Okay, let's try one more. So angle that we'll be working with will be 380 degrees. Now, what happens if we add 360 to this? Well, if we add 360 to it, we're okay. We'll have 740 degrees. That's a positive, and then we're good. But now, what happens if we subtract 360 from it? Well, if we subtract 360 from it, we end up with 20 degrees, which doesn't satisfy our initial question. We need a positive angle and the negative one. So if you don't get a negative angle on your first try, all you do is just subtract another 360 from it. You subtract another 360 from this measure. So it can be multiples of 360. So if I subtract 360 from it again, I end up with negative 340. And these are my two coterminal angles for 380 degrees. Now, reference angles are very helpful when figuring out trigonometric functions. So we have to figure out what reference angles are first to know how to use them in the future. So a reference angle is the positive acute angle formed by the terminal side of an angle and the axis. So let's write that down. So this is the positive acute angle formed by the terminal side and the x-axis. So let's look at an example of a reference angle. So I'll draw my y and my x-axis, and then we'll draw an angle in standard position. Okay, so let's read the definition again. So it's the positive acute angle formed by the terminal side and the x-axis. So it's an angle. So it's the quickest way to get back to the x-axis. So this right here this is our reference angle. A lot of times it's helpful to think of it as the quickest way to get back to the x-axis. Once again, this is going to be helpful for us when we start doing things with trigonometric functions and finding trigonometric values of angles measuring greater than 90 or less than 0. Alright, let's find the measure of the reference angles for each of the given angles. So for our first example, we'll say that theta equals negative 130 degrees. So let's draw this angle out. And negative 130, these are all in standard position. So you start here, here's 90, then I have to go 40. So this is negative 130 degrees. So think, it's the quickest way to get back to the x-axis. So I obviously wouldn't go to the right, I would just go straight up. Now this is negative 130. What is the measure of this angle right here? Well, if I'm at 130 and I want to get to 180, I know this has to be 50 degrees. And remember, reference angles, they're always positive. So the reference angle for negative 130 degrees is 50 degrees. Alright, let's try one more. Let's say that theta is 280 degrees. So we'll draw this out. It's really helpful to draw these out so you can visually see which way you're working with. So 280 starts here, goes 90, 180, 270. Then I need to just add 10 more. So right here I have 270 degrees. And my angle is 280. Now think, this here is 360. I have to get back to 360. So how do I get from 280 to 360? Just add 80. So my reference angle here is 80 degrees. So in this section we're going to have to learn how to find the value of a trig function. To figure out what that means, let's start off with point P. Now point P is just going to be an x and y point somewhere on an x and y plane. So let's draw an x and y plane, and then we'll just draw some random point P. Let's say P is the point somewhere here. So we say that P has an x value and P has a y value. Now P lies on the ray of one of our angles. So we have an angle here called theta. Now if I want to find the trig values of theta, what I have to do is create a triangle. And not just any triangle, it has to be a right triangle. So what I do is I take this ray and I extend this to become a right triangle. Now, once I've made this line a right triangle, I can use my knowledge of trig to find all the trig values. So we don't know what the length of this side is exactly, but we know it's on the x-axis, so we'll give it the value of x. We don't know the length of this side right here, but we know it's on the y value, so we'll say the length of it is y. Now this makes sense because let's say this was 4 and 5. This would be 4 and this would be 5. But we're going to just say that we don't know those for now. So we'll just name them x and we'll name them y. So now we gave two variables to the legs of the triangle. How about the third side? Well, for now we're going to call it third side r. So now that I have my variables for each, I can figure out the trig values. So remember my trig functions are sine, cosine, and tangent. So if I wanted to find the sine of theta given a point on an xy plane, I remember that I can use sine, cosine, tangent, or SOHCAHTOA. Now I know that sine is so opposite of theta would be y, and the hypotenuse is r. For cosine, I use ka. Adjacent to cosine is x, and the hypotenuse is r. And for tangent, it's TOA. So opposite of tangent is y, and adjacent is x. Now for tangent, only rule is that x cannot equal 0, because obviously we can't divide by 0. So if we were given a point on an x and y plane, and we were asked to find the trig values of theta, this information helps us to do that. Now let's find the value of a trig function. Point P is 4, -5, and it's on the terminal side of angle theta in standard position. Let's find the exact value of the 6 trig functions for theta. Okay, so first thing that we should do is we should plot point P. Okay, so we have our x and y plane, and point 4, -5, here's 4, -5 will be about here. So here's our point. So what we have to do is we have to draw this angle. So we have to remember that this point is on the terminal side of this angle, which means this angle really starts right here and travels all the way to here. So now, once we have drawn our angle, we have to create our triangle. So very similar to the previous slide, we just find the reference angle and go back to the x-axis. So there's our triangle. Now to draw the triangle, always go back to the x-axis, the shortest way possible. It just makes drawing it much easier if you do it that way. So to draw a triangle, always go back to the x-axis. Okay, so now, basically I have this triangle here my angle theta is this one here. It's the one that's closest to the x-axis. Now, I know the measurements of the side of this triangle. I know the top of the triangle is 4, and I know this side is 5. Now, if you remember from geometry, if you have a right triangle and you know 2 sides, you can find the third side. That's our second step, is to find the third side of the triangle. How do we do that? We use the Pythagorean theorem. So we know that the Pythagorean theorem is a squared plus b squared equals c squared. In this example, we're trying to find the hypotenuse. So we do 4 squared plus 5 squared equals, let's change c to r, because we called this r, to r squared. So that gives us 16 plus 25 equals r squared. 41 equals r squared. So the last side is r equals the square root of 41. So now, once I've found all 3 sides of the triangle, the last step we do is to find the 6 trig functions. So let's start off with the first one. So first we have to find a sine of theta. Now sine is just y over r, or opposite over hypotenuse. So we have negative 5 over the square root of 41. Now we can't have a square root in the denominator, so we change that to negative 5 times the square root of 41 over 41. Next one, cosine. Cosine is x over r, or adjacent over hypotenuse. So that becomes 4 over the square root of 41. But we can't have that in the denominator, so it becomes 4 times the square root of 41 over 41. And then tangent of theta is y over x, or opposite over adjacent, which in this case is negative 5 over 4. Now the reason we have to remember that these are negative is because this original 5 here was negative. So this 5 here is technically negative 5, and this 5 here is negative 5. So those are the first 3 trig functions, and we know to find the other 3, we just flip all of these values. Alright, that's the end of our video for today. Thank you and take care.